The desk isn't big enough.
I guess if I get
Or
under
the
desk
chairs
there-
are too big.
Yeah, I'll sit with this.
You're behind me. It's like
I'm the peanut gallery
Yeah.
this time.
All right. Hi, everyone. Welcome to Space Club. My name's Danny Bednar, part-time assistant professor in the Department of Geography and the Environment at Western University, where I teach about space exploration. And with me, as always, is Phil DeThrill-Stuke, professor emeritus in the Department of Geography and the Environment at Western University, and author of it's new still, right? We can call it new.
It's new.
Yeah.
Hot off the presses.
The brand new book.
Still warm, eh?
Yes, because I've been holding it so much from reading. The International Atlas of Mars Exploration, Volume 3, Curiosity, Insight, and Perseverance. Ingenuity didn't make the cover, I guess, but
yeah, and let me tell you that in China, they're upset that Zhu Rong didn't make the cover.
You know, someone else left Zhu Rong out of their book. You. We didn't actually plug me in The Martians. I don't think I have a copy here. Next episode. Yes. Poor Zhu Rong getting left off. But anyways, Phil, say hello.
Hello.
And also with me, Tanya of Mars, of Mia and the Martians fame.
It's definitely what I'm best known for.
Yes. Rock geologist and Mars geologist here to talk about Pluto with you here today. So Phil, I don't have much else to open up with, so I'm gonna hand it over to you pretty early, and we'll chime in as needed.
Okay, that sounds good, and I'll just get you to advance the slides every now and then. Okay, let's start looking at this. Oh well, if you're ready to actually go into it, I'd like to look at.
Well, you told me.
Yeah, when I ask. Okay. Anyway, what I wanted to say about this picture is that it is approximately true color, as much as that means anything. But often we see pictures of Pluto that are very sort of intense colors, and they're exaggerated. The contrast has been exaggerated, but this is roughly what it would look like. Has a slightly pinkish tinge. That's because of carbon compounds. Carbon in gases like methane in the atmosphere and on the surface, which get changed by things like cosmic rays and solar ultraviolet photons and so on, and they will change those carbon compounds and make them join together in different ways, and often those chemicals have a kind of pinkish color, and that's probably what is coloring this. But you can see that this is a high contrast world. You've got very bright areas, you've got very dark areas. So okay, now let's go to the next slide.
Hold on. So this is Pluto's new profile picture, for the lack of a better term. I get it, the default Pluto picture now, and it's good because it's, like you say, it's true color. It's got the Sputnik Planitia heart, which we'll probably talk about.
Yeah.
True color, though, I want to talk about. For my students and anyone else watching who's not a remote sensing guru, true color, by my understanding, is if we were in a spaceship, us sighted humans who aren't colorblind, who have kind of nominal sight, if we were in a spaceship around Pluto, this is what it would look like to us.
Yeah, I think that's the basic idea. Yeah, but these things are kind of difficult to work out. It's very hard to really establish exactly what true color means. So let's call it approximately true color.
Right. But the reason we talk about it at all is because very often, and we'll see some of these images later in this episode, is that oftentimes the materials which are reflecting different wavelengths of light are emphasized, or those wavelengths of light are emphasized to show off these regions we want to talk about. Mm-hmm. So you'll get blues and greens and all sorts of things that we wouldn't see if we were looking at Pluto from a spaceship. It doesn't mean they're not there. This gets into the visible light and the spectrum of electromagnetic radiation. But I do get a lot of students often confused with, like, why are there pictures of Mars that are blue? And I'm sure you get this all the time in your Mars talks. And we're highlighting some sort of material that's giving off blue. It's just not a blue we see, except for in that image.
Yeah, we don't always want to take a picture that is just, here's what this looks like, even though that's cool. And everybody, like as a human, I think wants to know what would this look like if I was staring at it. But as a scientist, we want to be able to pull out things like what minerals are in these rocks, or what is the grain size of one rock versus another rock, because that can tell us how they formed. And so we use a lot of false color views to pull out those details. So it's not meant to be a fake view in the sense of, well, this isn't exactly what you would see. We've done that intentionally because we're looking at it to pull more data out of the image than we can see with our eyes, because we're not really good at analyzing minerals with our eyeballs, but we can with more data.
And one day I want to do a whole episode on this, because I think everyone is, I mean, it took me years to be comfortable with the concept and understanding essentially remote sensing and seeing things in different wavelengths and different filters. And it can be very helpful and just kind of break down a lot of barriers. But that's not what today is about. Today we're talking about Pluto, which we've seen in a good amount of different colors. So good to move forward.
Yes. Okay, so let's just go back a little bit to just before New Horizons, the spacecraft New Horizons went to Pluto. The best views that we had of Pluto at that time were from the Hubble Space Telescope. But even Hubble can't actually see Pluto clearly. If you do a search on the internet for Hubble Space Telescope images of Pluto, probably the image you're most likely to get, or something similar to it, is these three big images on the screen. But they're not really images of Pluto as such. Basically, what the authors have done here, Mark Buey and his colleagues, have done is to take a bunch of images showing Pluto as it rotates, as I said, viewing it from different positions, and they work out a pattern of markings on Pluto that would create those little fuzzy images. And the kinds of things you really see in a real image of Pluto from Hubble are like those little pictures on the top. They're very fuzzy. You can see there's some little bright spots. You can see there's some little dark spots, but you can't see them clearly enough to really do very much with it. But if you kind of do some computer modeling and you work out what pattern of markings on the surface would show up like those little images, then you can make a map of those sort of estimated light and dark markings, and then project that map onto a sphere, and you get these computer rendered images at the bottom. The clue that they're computer rendered and not the original images is just how sharp the outline is, the limb or edge of the disk. Very sharp there, because that's a rendered image. The map is projected on a sphere and we're looking at a picture of it. But the original images are very fuzzy little things. But take a look at the middle image of the big ones, one that's labeled 180 degrees longitude. It's got this big bright spot on it.
Yeah.
There's a dark spot on each side of it in the southern hemisphere. Yeah. So that feature was known before the New Horizons spacecraft got there, and the flyby was timed specifically so that hemisphere would be in view, because this shows the greatest contrast of bright and dark on the surface, and they wanted to see what was going on there. So they specifically timed the flyby so they get a view of that bright spot. And that indeed is what we saw in the previous image. This big, roughly sort of heart-shaped bright spot with a dark on each side of it in the lower part, the southern hemisphere. Okay, so yeah.
So as a reminder, so Pluto 39 AU, I believe, away from us.
Yeah, right.
So 39 times the distance between Earth and the Sun. It's a 10-year flight, and they timed it so that when it flew by, for the most part, it would be looking at this hemisphere, which is
that's amazing.
That's pretty good foresight. I didn't even really think, like, I wouldn't have been surprised at all if you were like they were just gonna get what they get, right? Like kind of like the Mariner style of like.
Oh no. Very much cleverer than that.
I wouldn't have been surprised, but I'm also not surprised that it was planned to see that feature and that it worked.
Yeah, oh yeah, it was important. But the timing of the flyby isn't set at the moment of launch. You have lots of opportunities during those 10 years getting there to make very small adjustments to the velocity so that you can time exactly when you're going to get there.
That's still mind-blowing that we can be that precise for something that far away. It's also heartbreaking to say, oh, we can only get one hemisphere. We got one shot at this. The whole other side of Pluto, mystery. We don't get to see it yet.
Right, yeah.
We can guess.
Okay, so let's move on there. So what did they see? Well, there's that big white spot, the sort of roughly heart-shaped spot, and the big dark area to the lower left there on Pluto itself. And you just see a hint of the dark area on the other side of the heart, just on the right, yeah. And also there's that big moon. Pluto was known to have a big moon, and there it is, a beautiful big moon. It's a little bit darker, but it does have a big red spot on it again. So yeah, very, very interesting places.
It has a big red spot that, at least in this imagery, seems to share color.
Yeah, and it does. And in fact, it's so similar in color that some people suspect that in fact that red stuff has come from Pluto.
I could be a planetary geologist.
Yeah, some of that stuff could be. Now, I'm not sure whether the idea is that the red stuff itself has gone from Pluto to the moon, or whether methane in Pluto's atmosphere has been stripped away by the solar wind and captured by the moon as it goes by, and then it turns red when it gets there. I'm not sure about that, but anyway, never mind. But there may be an association between the two.
Don't you want my hypothesis? See this little crater? There was an impact event that shot up all this red stuff that landed on Sharon.
Oh, all right, there you go.
Yeah.
Okay, I'll take your word for it then.
Give me my PhD. You
did another one.
Yeah, this one in planetary science. You didn't mention the name of the moon. I know you have a story about that name. Are you getting to that, or do you want to talk about it now?
Oh yeah, well I do. Yes, I remember a professor at the University of Victoria took me to task. Well, he didn't really take me to task. He took everybody else in the world to task for pronouncing the name of the moon Charon. And he said, if we in Greek that should be Charon, and he's right. The name does come from Greek anyway, and we should really call it Charon. But most people call it Charon, and there is a reason. When that moon was discovered back in 1978 by James Elliott, who was at the U.S. Naval Observatory, he wanted to name the moon after his wife, which is very touching. And his wife's name was Charlene, spelled with a CH, Charlene. Everybody called her Char. And so he went looking for a mythological name associated with Pluto that looked like that. And this is what he found. He didn't really know that it was pronounced Charon, so he always pronounced it Sharon. And a lot of people do because of that. So I think you can choose how you want to say it. It doesn't matter.
Yeah, I've gone full on into calling it Sharon, which wasn't even her name. It was what'd you say it was? Charlene?
Charlene, yeah.
Okay. Well, I might start calling it Charlene. Charon, was he the boat? Because
that's right. The operator of the ferry across the River Styx that carried souls into the underworld.
Right.
Yeah.
Because everything. Wait, is there a reason it's afterlife related? Is that a Pluto rule?
Well, Pluto, king of the underworld in Roman mythology. Yes, it's associated with the afterlife and the underworld. Yeah.
Right. Okay.
So let's zoom in a little bit on that heart. Probably its most famous feature. We're looking at a world that is smaller than our moon. It's about 2,400 kilometers across, only about 2/3 of the diameter of our moon. So it's quite a small object. And it is so far from the sun. It's very, very cold. So anything that we think of as a gas is likely to be frozen there. A lot of this moon is made of water, but water that is frozen as hard as rock. And other gases like carbon dioxide and methane and so on would also be ices on its surface. But even nitrogen, which has a very low boiling point, can freeze on the surface. There's a thin atmosphere that is nitrogen, but it can condense out onto the surface, rather like on Mars. Carbon dioxide forms the atmosphere, but it can also form ice at the winter pole. So the nitrogen is doing the same thing here. And that big white area, in fact, is a nitrogen glacier. It's molecular nitrogen frozen onto the surface, but still soft enough that it can flow a bit. So it flows into low areas. And the big white area that is full of nitrogen ice there is probably a very large impact basin, the biggest impact crater or basin on Pluto.
I don't know if we'll get to it, but in terms of feature names, like...
Oh, we will get to it. There's a slide with some names on it, so we'll talk about that when we get to it.
And this region as well, I think, wasn't it quite a bit younger than anything that was expected?
Well, yeah, that's the thing. Now, because this is nitrogen ice and it's soft enough that it can flow a little bit like a glacier, it's not going to actually accumulate any craters. If an asteroid smashes into that white surface and digs a crater, and that crater sits there, after, I don't know how many years it would be, but let's say 1 million years or so, it started to soften as the ice and that formed a rim kind of sags down a little bit, flows outwards. So stuff would flow into it to fill it up. After maybe 10 million, 15 million years, it's all gone. It's erased. Pretty much what you'd expect if you had a meteorite impact in Antarctica and the ice. There would be a crater there for a little while, but pretty soon it would be gone. It would be filled in with stuff. The walls would flow down into the floor, and it would just kind of gradually anneal, and it would be gone. So that's what's happened here. So that is a very young surface in the sense that it's constantly being reformed as this ice moves around a little bit. There seem to be kind of convection cells in this ice, so it's mixing up all the time. There are flow features, so it's flowing. So what we see is a young surface.
Yeah, and for frame of reference for everyone, the solar system, roughly 4.5 billion years. Most of the last 700 million years has been relatively stable. And a lot of surfaces, especially out this way in the outer solar system, are quite old. But if it's just in the 1 to tens of millions of years, that's very young for out there.
Mm-hmm. Okay, let's move on. So here's a close-up of an area with quite a lot of craters on it. Now that looks like quite a lot of craters, but if we were looking at the moon, the highlands of the moon, the bright areas when we look up at the moon, they are just like wall-to-wall craters. So there aren't as many craters as that here. There are lots of spaces between the craters. And that tells us that even the cratered parts of the surface are actually younger than the very ancient parts of the moon. Something has happened that has erased most of the really ancient craters. Perhaps it's melting or fracturing or something that has broken up the surface and hidden most of the really old craters. Maybe say about 4 billion years ago that might have happened. And what we see now is the craters that have formed since then, but it's not as many craters as there would be if we had a complete record all the way back to the very beginning of the solar system. So it's quite an active surface. And this wasn't I don't know. People didn't really know what to expect, but it's there's some activity going on here, even though this is a small object and very far away from the sun. But something drives geological activity, and we can see all these fractures cutting the surface. That's a sign of geological activity. Something is breaking up the surface, fracturing it. If you get enough fractures, they start to make craters difficult to see. And you can see sort of just below the middle of that image, there's a place where a crater is cut through by big fractures. And yeah, that's the one. And if there were more than just those couple of fractures, then the crater would actually become quite hard to see. And the more fractures there are, the more they get destroyed. We don't, in some areas the surface may have been altered by the surface melting and flowing like lava flows. In other places, it's been broken up by fracturing, but something has erased those very old craters. So this isn't a primordial surface like, say, much of the far side of the moon, for instance.
So I have another theory, which is what I like about planetary science is that once you kind of know one mechanism or a few of them, you can just randomly throw them out at everything you see. So Pluto is tidally locked essentially with Charon, which in other environments, in other tidally locked environments, we see that creating some sort of activity. Could that be at all related to the fracturing?
Well, that's possible. Yeah, I don't know if we really know enough about the exact circumstances of the Pluto system to know that. The best known example of that sort of thing that you're describing is Jupiter and its moon Io, which is covered with volcanoes. Io is tidally locked to Jupiter. And actually, if that's all that was happening, if it was just tidally locked and it just went orbiting around all the time, there wouldn't be any volcanic activity. But because there are some other big moons around it that disturb it slightly, they knock it slightly off of that tidal lock. And that produces flexing in the surface and the interior that heats it up. Now, that might happen here, but I just don't know if we really know enough about exactly what's happening with this. But it could be something like that.
A third body to throw things off.
Yeah, something, because like all the moons, the weird moons of Jupiter all have like resonance with Jupiter and like one or more of the other moons. So that causes all the flexing and stuff. Same thing with like, I think Enceladus also has a resonance going on with Saturn. So I feel like Pluto and Charon together is probably not, there's not a big enough mass differential. But if you had some other third body, maybe this is planet X. There you go.
Or Neptune. That's tens of AUs away, or at least 10. Okay,
let's move on then. And this is just another part of the surface. These are somewhat exaggerated colors now, but they help to show areas with different compositions. There are all sorts of different things that could be going on here with
yeah, I mean, this seems like pretty pronounced of a like.
Right, that's the edge of Sputnik Planum there. But the whole surface, you can see it's broken up. It's got fractures. Parts of it look like they've been eroded in some way, maybe by cycles of freezing and thawing, as I suggest there. And there are all sorts of compounds that can produce odd colors here. For instance, ammonia and other nitrogen-rich compounds like that that could be present on the surface, and with sort of melting every now and then. The melting point might be reached, and it could melt and soften and flow a little bit or evaporate away, and then it all freezes again. And you kind of have lots of opportunities for activity like that. Right at the bottom, the part that has sort of grey and white splotches at the bottom center, that's part of Sputnik Planum again, the white heart shape, but with weird patterns on it. And if we go to the next slide, we can see it closer.
Looks like coffee cake in that other one.
Yeah. So that's Sputnik Planum. When you change the contrast so it doesn't just look white, there's a lot going on in it. So it's very active. But the whole surface has clearly had a lot of activity. This is not at all a kind of boring world that hasn't done anything for 4 billion years.
Yeah, and I mean, this is another good example. Like, again, not being a planetary scientist myself and talk to my students all the time about planetary science, and like, it's part detective work and part archaeology almost, but like physical. But like, this is a good example of like, anytime you see, well, this is different from this. Typically, like, difference means something's happening or has happened. Now, it could be something entirely mundane and not interesting, and that's why you should ask a real planetary scientist, like, is this interesting? But if you see things like this, it typically means the world's pretty interesting, in contrast to, there's not that many things that are totally boring, but like Mercury in visible light mostly looks the same. There's things you can pick out depending on what you're looking at it in. But Pluto, I think, in almost any imagery, you don't have to be a planetary scientist to know, like, things are happening. Like, there's cracks here, so something's happening there. This is an impact crater. This material looks slightly different than this material. So you can start to get a sense of like which bodies are more interesting than others. Not to boring shame other bodies. But
Yeah. All right. Let's go in one more step to close up. So this is the edge of Sputnik Planum in one of the closer images. You've got the mountainous area outside Sputnik Planum, and then the what looked before like a smooth area inside it. But as you zoom in, you see that it's divided up into these blocks with little dark lanes between them. People think that they might be convection cells, where the ice is convecting, so it's sort of like water, let's say like a pot of soup coming to the boil. And you see it sort of rises up in one area and flows down in another. That may be what's happening there. And even the surfaces have little pits and markings on them. You can see closer up. So at every scale, it's more and more complicated. All right, and now we get to see a few names. Yeah, so that white heart is called Sputnik Planitia. I called it Planum by mistake. I shouldn't have. It's
I called it Planitia earlier, and I didn't want to call you out because honestly,
I made a mistake. Sorry.
I assumed I was wrong.
Yeah. So no. Anyway, here we go. Some of the names are associated with the discovery of Pluto itself. Tombo Reggio is named after Clyde Tombaugh, who discovered Pluto.
And his cat.
Sorry?
What? Clyde Tombaugh very famously had a cat named Pluto, I'm pretty sure.
Oh, very good. All right.
There's a picture of him with his cat, which is all I know.
And when he died and was cremated, a tiny little portion of his cremated ashes were encapsulated in resin, and they were put on the spacecraft. So he went to Pluto.
I didn't know that.
If you look up just at the top of Sputnik Planitia and then off to the left, you'll see the name Bernie. That's named after the young woman who suggested the name Pluto at the time when they were looking for a name. I think her name was Virginia Burney, if I'm remembering correctly. And then a bunch of other names come from spacecraft missions. We have Voyager Terra, Pioneer Terra, Hayabusa Terra, Japanese spacecraft that went to an asteroid. So there are some names like that. And others that are named after people who've studied Pluto and the outer solar system.
Feels like it could be a little confusing naming features on a planet after missions that never went to that planet.
Mm-hmm.
Well, I know. There's Vikings in there as well.
I used to confuse New Horizons and Rosetta, like when they were like like happening.
Mhm.
Yeah.
Because it was the same timeline roughly. What was that? Is here.
Right.
Picard with 2 C's, so it's not Jean-Luc.
In general, I feel like we're very uncreative with our naming. Like, I love how, like, if you go to UBC, for example, on campus, a lot of the buildings have indigenous names. I forget if it's which tribe it's from, one of the Salish tribes.
Yeah.
And a lot of them are very descriptive. It's like, oh, the land where two waters meet, or the stand of trees, or something like that. And I love the idea of thinking about, like, if we're naming a place on a new world like this, what would the names be that we could give it that are more like of that place, rather than just kind of taking the old tactic of like, we're naming it after some people or some towns that already exist on Earth and now we'll put it on another place. Like, if you were going to describe what Sputnik Planitia looks like, what name could you give it that might be like, unique to Pluto,
evocative of what it is?
Yeah.
I mean, so yes, I totally agree. Although in fairness, we do use old Roman names that are somewhat descriptive. Like, doesn't Planitia mean plain?
Yes.
Yeah. Though I don't even know if that's accurate to what Sputnik Planitia would be described as. But yeah, it would be cool if we more like, especially on Mars, where we get like, if there is a term that could convey like water opening up, to like name some of the deltas or something. Like, yeah. I don't know, Phil. That's another episode I want to do one day about naming. I know you have a ton of expertise in this area.
That would be interesting.
Stuff. Yeah. Do you know Safronov? I feel like you always know who the Russian people are.
I believe an astronomer who studied Pluto in the outer solar system, but I don't know the details of that.
Whoop.
Spoilers.
Oh, speaking of spoilers, it has an atmosphere.
Oh yeah, there you go. A very thin atmosphere, but when we were looking at those previous views of Pluto seen as the spacecraft's approaching, you can't see an atmosphere around it. But when you get back, when you're beyond Pluto, looking back, now you can see sunlight filtering through the atmosphere. It's easier to see very faint things that way. This is the layers of haze in the atmosphere. Quite a complicated atmosphere, obviously. But it's very, very thin. I think I forgot to look up the number, but it's something like only 1/10,000th of the density of Earth's atmosphere at the surface. Very, very thin. I mean, if you were there, it would almost feel like you were in a vacuum. It's so thin. But even so, there's enough atmosphere that the sunlight filtering through it can actually illuminate things on the night side. We can see the line called the terminator between day and night at the lower part of that image. And the way this is processed, you can't see anything, but in some images, you can actually see features in that dark area illuminated by light that is just filtered through that thin atmosphere and illuminating the surface.
So if you were on the surface, do you think the sky would look a little bit blue, or do you think it would be just like staring into the blackness of space?
I think it would look black, personally. I think so.
So yeah, like roughly, did you say 1/10,000th roughly of Earth?
I think it's something like that.
But still probably that much more than like the tenuous gases around the moon. Like when
yes.
You never see anything like this. Like, you can get the best limb shot of the moon and you're not going to see anything, even though there's very tenuous gases hopping around there.
And this is like an order of magnitude less atmosphere than even Mars has.
Right.
Yeah.
Like moon, almost nothing. This, very little. Mars, also very little. Then I mean, there's other
Mars is a lot more than this, though.
Yeah.
Than Pluto.
Yes. Yeah. There's no parachutes that are going to help you here.
All right.
Well, yes.
Oh, and here's Charon, aka Sharon. Cool. Yes, the big moon. It's more than 1,000 kilometers across, so that's pretty big. Since it's about 40% of Pluto's diameter, it makes it sort of what people often call it a double planet in a sense. It's the biggest ratio of sizes like that among the larger objects in the solar system. So it's quite dramatic. And this is an interesting place too. You can see there's a lot of relief. We've got lots of craters. You're always going to see craters, or pretty much always going to see craters. But again, these are not the wall-to-wall craters of the highlands of the moon. Something has erased that ancient surface, and what was left has been cratered at a much lower rate. So we have these, still plenty of craters, but they're not wall-to-wall. There's lots of space between them. And then, sorry,
go ahead.
Yeah, so we've got a big fracture running right across the middle there. Yeah, so again, quite a lot of activity, and we've got that red spot up at the North Pole. This is oriented with north at the top, so there's the North Pole, which seems to be made of the same red stuff that we see on Pluto. And that red stuff is actually quite common in the outer solar system. And we'll talk about that a little more when we discuss some other objects in the vicinity of.
I was going to say, potentially stupid question, but I'm assuming this is, from Pluto's perspective, the far side of Charon. Like this is the side facing outward.
I believe I'm right in saying that this side roughly faces Pluto.
Oh, okay. So
I think that's right. Yes, I forgot to look up exactly where the zero meridian would be. The zero meridian would mark the point that faces directly to Pluto.
Right.
But I'm pretty sure that this is the side that faces Pluto.
Right. Yeah, I guess that makes sense as well. Oh.
Pluto has a bunch of little moons too. Here they are. Nix and Hydra, the larger ones, were discovered by the Hubble Space Telescope when it was imaging Pluto. They were deliberately looking for little moons as potential targets for New Horizons, and they found a couple. And then as New Horizons was approaching the planet, it found two more, Styx and Kerberos there. All these names are again associated with the underworld. So yeah, they all come from that. The one that was seen most clearly was Nix, and although this is just a monochrome image in color, there's a red spot on Nix as well. The feature that looks a little bit dark in this one is actually red. So yeah, right there. Yeah, that's right. So this red stuff is distributed quite a bit, not just around the Pluto system, but in other objects as well. So there were quite a lot of objects to look at, and they did a very thorough search for more moons, but didn't discover any more.
Do we know offhand any of the distances on these? Are they quite a bit further out than?
Oh yeah, they're further out than Charon. Yeah.
Oh.
All right. Now, Pluto is not the only big object out there. This is an image that was put together showing some of the larger objects in the outer solar system, the Kuiper Belt. And when this was made, the one called Eris was thought to be just a little bit bigger than Pluto. And we now think that it's just a little bit smaller because people had underestimated.
Got to update my slides?
Yes, I'm afraid so. But you can see from this there are quite a lot of little moons of these objects. So moons of these worlds are quite common. Pluto there is only showing Nix and Hydra, but not Styx and Kerberos, the others. This was made before they were discovered. So yeah, there's a lot of variety. This shows some variation in color. and there's quite a bit of variation in color of these objects as well, which suggests different composition, and we don't really know very much about the details of all of these things, but suffice it to say, there are a lot of potentially interesting worlds out there, and there's no reason to think that if we could fly a spacecraft past Eris or Sedna or any of these other worlds, that they wouldn't be just as complicated and interesting as Pluto. That we, at the moment, we don't know all the details of that. Because Eris was thought to be just a little bit bigger than Pluto for a while after it was discovered, that was why Pluto eventually got demoted from planet to dwarf planet. Because the idea was, if we're going to call Pluto a planet, and then we discover something that's a little bit bigger, we ought to call that a planet. So now, instead of having 9 planets, you'd have 10. And then if you discovered something else, you might have 11. And the number could potentially keep growing. Yeah, and they decided, well, let's not do that. Let's just take all of these things that are still quite small, but in that kind of size range, and give them their own category. And it wasn't really meant to insult Pluto, but a lot of people, of course, took exception to that because nobody likes change, as we know. So anyway, all sorts of interesting things here. So let's go on and have a look at some of these.
Hold on,
whoa.
You got into Pluto's demotion, which
okay.
used to be a topic of much debate. I feel like it's probably settled down, or I just don't come across it as much. I remember you talking about this in the original Space Club when we used to do this in person. Like, to you, it didn't really matter. But if you wanted to be, attached to Pluto's standing, I mean, it went from being the tiny odd one out with this crazy highly elliptical orbit as well, to being the king of, or at least the co-king with Eris, of a different category. So it went from being the small fish in big pond to big fish in still a big pond. Also, what was the other story on that? I don't know. Do you care if Pluto's a planet?
I feel like I care from a nostalgia standpoint, because like growing up thinking of Pluto as a planet, it holds a special place in my heart. And I will say, in like public outreach talks, a lot of people will ask, do you think Pluto is a planet, or do you still consider Pluto to be a planet? So I think for people of a certain age, it's still something that they're interested in hearing the opinions of space experts from. I remember when I first came to Canada, when I was like crossing the border to get my visa and everything to go to Western, I crossed the border at 3 a.m. in Sarnia, and on your visa it says what you're studying, and so it said geology, and they asked what I studied, and I said Mars. And because there was no one else at the border crossing at the time, the border guards all started asking me a bunch of questions about space, and one of the first ones was, do you think Pluto is still a planet? And I'm like, oh, since my answer is yes, maybe this is going to help my immigration process. It was a lot of fun.
Interesting.
Yeah.
Your Canadian Border Services has a policy on whether or not we let you in based on your Pluto answer. So these are all dwarf planets, minor planets. The TNO title is just a catch-all for astronomers. Anything past Neptune, but still in our solar system.
Yeah, right.
It's a TNO. And a bunch of them are tiny little things that just have names. These are all the bigger ones with names.
Well, is it specifically things that cross the orbit of Neptune?
I thought it was things that were...
No, they're beyond Neptune.
Oh, okay. Because it says like trans-Neptunian objects, so it kind of sounds like it should be in that Pluto category of like wonky orbits.
Right. You think it'd be post-Neptunian objects.
Yeah.
Because trans implies, like some sort of crossing. Mm-hmm. But in terms of dwarf planets, the other big one for that category, not a TNO, is way closer to us, Ceres. But it's in this size category, roughly.
Yeah, right.
And it's also considered a minor planet or dwarf planet.
That's right. Yeah.
And it's in the asteroid belt.
Right? Ceres is about the size of Charon.
Oh, okay.
Oh, okay. I would have even... Okay. The other thing I wanted to ask, when you see, because we got some time, when you see these like mosaics comparing different bodies, is there an accepted rule that they should all be in the same color universe? Like Do you know what I mean? Like
like
yeah, like these should Pluto and Sedna should, like, whatever rule you're using, whether it's visible, true, false, but which false, it should be the same for all 8.
Mm.
Do you think
Well, that
that's
sounds reasonable. Yeah.
Yeah. I think the other thing that could be skewed heavily is like relative brightness.
Yeah.
Or like albedo, I guess, if you want to be technical about it.
Yeah.
Like if Eris and Pluto were right next to each other, would Eris look brighter than Pluto or not?
Oh yeah, I think this graphic has been deliberately created to show the relative brightness and something of the visible light color. So Eris and Haumea, let's say, and Quaoar and so on, they're neutral in color, but some are brighter than others. And then some of them have this reddish tinge. I think this is deliberately set up to make things look roughly the color and brightness that they should be.
Okay.
Oh, speaking of that wacky orbit.
Yeah, there's Eris with this very elongated orbit. Right now it's far away, getting on for twice as far from the sun. Yeah, about twice as far from the sun as Neptune, but it can come as close as Neptune, as we can see from that. Yeah, very variable. But these things really are a long way out.
Yeah, so I use this exact image in one of my slides. So this is the Kuiper Belt, these white things.
Yeah.
The inner solar system doesn't even really resolve on this image. Just
No, right.
at this scale, everything inside Jupiter, there's everything we have ever known.
Yeah.
But that's, yeah, the moon, Mars, Earth, Mercury. I mean, the sun would be tucked away in the back. But it's funny, I called Pluto like highly elliptical. Like it is in the sense that compared to the other planets, which are almost circles, but like in terms of actual highly elliptical orbits, it's not. Like Eris is more elliptical.
Yeah, that's right. Pluto's orbit is a bit elliptical.
Yeah.
Yeah.
Yeah, I was just, but then some of the planets are almost zero, like they're almost circle, but not quite.
Okay, let's move on there. This is Makemake with its little moon, which hasn't been given a name yet, as far as I know. I'm surprised it's not named, to be honest. But this is just an example of the kinds of things that we can know about these worlds, even though we don't see them close up. Spectra suggests that this is covered with methane ice, and it seems it possibly has a very thin methane atmosphere. And infrared studies seem to show that there might be a warm patch on part of its surface, which I saw suggested to be possibly caused by some kind of internal activity. But I'm not sure if they're ruling out the fact that it might just be quite dark and therefore it warms up more in the sunlight. I'm not sure about that. But basically we can tell things not just by looking at them, but also by measuring heat using infrared wavelengths, in spectra that show the composition. So there are all sorts of things that we can still try to find out about them, even though they're so far away.
I just want to jump back here. I think, maybe it's not. So KBO up here, Kuiper Belt, Kuiper Belt object. So it's obviously just an object in the Kuiper Belt. And I was going to say all KBOs are TNOs, but not all TNOs are KBOs. But I don't think that's true, because I think there's KBOs inside of Neptune.
Yeah, well, there could be. I mean, I think that these kinds of labels should be used a little bit sort of loosely.
I like labels, Phil.
Oh. Well, I can't help you then. I'm sorry. But,
I mean, we're also not looking at the most scientific visual in the world, but in terms of accuracy.
Well, sometimes Pluto is closer to the sun than Neptune, and if it's a KBO, then Yeah, there's a chance for KBOs to come in a bit closer to the sun than Neptune.
Right.
When we were kids, Pluto was closer than Neptune.
Yeah.
I remember waiting for the like distance to pass, like it was on the news or in
Yes.
Sky or something like that.
Nerd.
All right. Now here's a very weird looking object, Haumea. Now we get used to seeing things that are elongated, that are irregular shapes. Lots of asteroids, little planetary moons, comet nuclei, things like that. They can be elongated, but they're all small. This thing is 2,000 kilometers long, about 1,000 kilometers across at its narrowest point. That is big. And normally things that are that size have enough gravity that they will eventually squish themselves into a nice round shape. This one hasn't done that, perhaps because it's so far away that it's very, very cold and therefore too rigid to do that. Although it's also perhaps possible that this is a collisional remnant of something bigger that's had big chunks knocked off it, and what we see is a kind of a shard of a bigger shattered object, and it hasn't had the opportunity yet to turn itself into a sphere. But at any rate, this is by far the biggest non-spherical object in the solar system. I think the next biggest is probably Saturn's moon Hyperion, which is about 350 kilometers long.
I remember. Sorry.
Oh, okay.
I remember somewhere you had a blurb about you, and I don't know if you wrote it or someone else did. It might have been Geography website. You were noted as like cartographer of irregular bodies.
Yeah.
And that was like your claim to fame.
That's what that was my PhD, and what I did for a dozen years or more.
A little hop in your step when they discovered this? Were you excited?
I don't remember registering that, to be honest.
Oh.
I was too busy with other stuff. Oh well.
It's not even that irregular compared to some things you've mapped.
Well, now, it might be more irregular than this rendered image suggests. It could be a lot more irregular than that. But that does raise the interesting question of how you would determine what the shape of something like that is. Even with Hubble, you can't see that clearly enough to really tell very much about its shape. So the best way that we have to tell the shape of that is to watch it pass in front of a star. So you're looking at this object. It's very faint. It moves across a star image, and we see the star flicker off when this moves in front of it, and then flicker back on as this moves on again. That gives you basically a measurement across one line across that shape. But if you had another telescope set up, say, 40 kilometers away, and another one 100 kilometers away, and so on, several different ones spread out, each one would map a different line across that shape, and you could get a rough idea of the shape. And the more lines there were, the better that shape estimate would be. And this is called occultation, hiding something, hiding starlight, moving something in front of it. And really good occultations can have 20, 30, 40 different telescopes, 20 or 30, 40 chords across the shape. And they really do map out the shape quite well. So that's one way to do it. And people have done that with Haumea. So they've got a rough estimate of the shape. We haven't got really good occultation setups that have had lots of lines to really tell what the shape is. But one of those occultations discovered something quite bizarre, and that was that if you start looking early enough, something else will move in front of the star before Haumea gets there. And then as Haumea moves on, it hides the star, and then it moves on, and then something else hides the star again a little bit later. There is a ring around this object. A ring. It has a ring which shows up as a little occultation on each side of the main one. And that's how it was discovered. So let's move on to the next slide.
How do we know it's a ring and
not a spaceship?
I was say not moons.
Oh well, first, an occultation, well, first there would have to be two equally spaced moons. And it would be incredibly unlikely that you would actually capture that in an occultation. It's not impossible to happen, but it would be very unlikely. And then if you see another one and the ring is still there, the moons wouldn't be in the same place. So, there have been multiple occultations like this, mapping out that ring. So, it's bizarre. It has a ring. And it also has two moons. Now, the moons would be discovered in images from Hubble or perhaps other telescopes as well. James Webb is doing this kind of work now as well, and some of the big ground-based telescopes. So, two moons. It's got a ring, an irregular shape. I did show on the previous slide that there was a little dark reddish patch on the surface, which shows up. It looks a bit fuzzy there, but basically people have discovered that there's this one patch that has a different spectrum. This is a very unusual object with a lot of interesting stuff happening to it. And a flyby at that would be a really interesting thing to do if you could do it.
Whoa.
And it's not the only one. Quaoar was another of those ones. Quaoar was another of these objects that was on that that kind of composite image we had of 8 of these little worlds. In one occultation, people discovered a ring, and then when they looked at it again in another occultation, they discovered a second ring. It all depends when you turn on your observation and when you end it. So if you bracket the observation quite close to when the thing itself will do the occultation, then you're not going to see the ring at all. But if you start looking earlier and you continue looking later, you've got more of a chance to get a ring. And if you start even earlier and end even later, you've got more of a chance to discover additional rings. So that's what they've done. So this is an object that has a moon and 2 rings. So clearly, these objects are really interesting. They're much more complicated than we might have thought. And the chances are that every single one of these would be really interesting if we flew past them with a spacecraft like New Horizons. They're not just simple little balls of ice.
I mean, there's so much crap out there that these relatively larger bodies are probably, I don't know if they're collecting it or if it's from their formation process, but.
Well, I think most explanations of these things are sort of based on the idea that a very large impact on the main body blows stuff off it, some of which would fall back, some of which would be lost, but some remains in orbit, and that can form moons and it can form rings.
Well,
and that's all I have there. Okay, so an interesting part of the solar system.
Hold on. We didn't even talk about the mission that made all of this possible.
Yes, right.
We have a few seconds here.
Okay.
Oh, we're gonna go back in time here. Everyone remember. Okay, so before, I don't know what day it was, 2015. One day Pluto looked like this, and the next day it looked like this, and that's probably the biggest one-day difference other than maybe the Viking image, in like planetary science, versus like we went from a few pixels to this, because of the New Horizons spacecraft launch in 2004. No,
5.
6.
Right 6. Right.
One of those, and it took about 10 years to get out to the Pluto system. And do you remember watching the flyby or keeping up? You were probably.
Oh yeah, we watched it live in the lab at Western. That was pretty amazing.
Yeah, that's right. And of course, one thing about that is that because it's so far away, we weren't getting a flood of images one after another right around the time of the flyby. It took quite a while for these pictures, more than a year, for all the pictures to be transmitted. This,
I think Pluto's what, nine light hours away or something like that.
Yeah, something like that. Yeah.
Oh, right. So yes, right. We were 9 hours behind it actually happening, but that doesn't. I mean, it's the same for everyone, so it doesn't really matter.
Yeah.
I remember. Was Bill Nye hosting? Like for some reason, he's ingrained in my brain when it comes to New Horizons. I feel like he was hosting the like image reveal event.
If he did, I don't remember that.
I don't remember.
I don't know. But yeah, right around the same time, like the 67P landing, I think we also watched on the screen in the GIS lab.
Yeah. Oh, you know what? That's the one I'm thinking of.
Okay.
Because it was the ESA live stream.
Right. Yes. Phil, do you remember? Were you just on unmanned space flight, just keeping up?
Oh yeah, yes, I was. That's right. I was doing that quite a lot. Yeah, keeping up with it. But as I say, it's not like you suddenly got this great flood of images hours after the flyby. It took a long time to get them.
Yeah, but I do remember like one dramatic moment when I'm pretty sure it was Bill Nye was like, "Well, here it is, our first image from Pluto," and I'm pretty sure it might not have been this one, but it was like some. Oh no, because it was approaching, so it would have been from a pretty good distance. But I guess this event must have been the day they were going to have good enough images that it's like we should have a public event. Okay. Right, because as we're approaching,
there were some approach images.
Yeah, as we're approaching, we're getting slowly more interesting pictures.
Right. Yeah. Yeah, and it is worth pointing out that they were taking pictures during the approach so that they could see the whole surface of Pluto. So they start out looking at the side that we were going to see close up, but while it's far away, and then as it rotates, you gradually get to see more and more of the other side, and then you see in the other side, not in as much detail, but you are seeing it, and there's some markings on it, and it rotates, and now we're looking at the side from really close, and you're seeing all these amazing features.
And then as it flew by, it flew by and kept looking as it went.
Yeah, that's right.
So then it got images on its the opposite of an approach. And where's New Horizons now? Just shortly before we wrap up.
Well, right. So it just went on flying out, and people looked for something else it might fly by, and luckily they found an object, a little thing called Arrokoth, which it was a funny little sort of two-lobed asteroid object, very interesting looking object. And I should have included a picture of it here, and I forgot. They had another flyby about 3 years later, and that was a very interesting object too. And since then, they've just been flying out there, and they're still looking for something else. The chance of them finding something else they can fly by is very, very remote now. But they could still potentially turn something up.
Awesome.
The spacecraft's working fine.
Oh, well, it did its job anyways. But
yeah,
if we can get some bonus images, that's great. But otherwise, it did its job, and I guess so have we. So that's it for this week. Thank you so much, Phil, for your rundown of Pluto. Thank you, Tanya, for being here. As you may have heard the doorbell earlier, our guest is here to watch Star Trek and drink wine. So we're going to go downstairs and do that. And we will see you next month. Will next month be 2026 in space? Should we do that?
Well, I'm not quite sure about that, because it seems to me that a month from now you will be actually here with me.
That's true. We could do a live.
Yeah, you could do the reverse of this, you and Phil, and then I'm here remotely.
No, Phil's going to be busy.
No, I think we will wait until you're back home, Danny.
Okay. Yes, because I know you're busy also with other things. So yeah, a month from now-ish, after I'm home, late November.
Okay, but we could do looking ahead to 2026. That would be a fun thing to do.
Yes. All right. Well, thank you everyone for tuning in, especially those of you who have to, because you're my students, and those of you who don't have to. Actually, more thank you to you. Never mind. You're the one
chosen to be here.
Yes. Yeah. All right. Thank you, everyone. See you later.